So this is an experiment on psychometric process. We are having an air conditioning system. So first we must know what is meant by air conditioning system. So air conditioning for human comfort or for any industrial process that requires certain processes to be carried out on air to vary the psychometric properties of air to requirements. You have to decrease the temperature of air. So that is the main purpose of air conditioning system. So this process may involve the mixing of air streams, heating of air, cooling of air, humidification of air, dehumidification of air, and a combination of the processes. These are the things we have studied in study of air conditioning, which includes psychometric process. So that processes can be carried out with this experiment. All such processes are studied with the given air conditioning test rig. So this is the air conditioning test rig. So we are going to find how we are reducing the values of temperature from inlet to the exit, and also we are finding out how the processes of psychometry are carried in this experimental test rig. So first, this is a vapor compression air conditioning test rig, so which is designed exclusively for study of the refrigeration properties with air conditioning and environment of correct temperature, humidity and air movement. So this test rig consists of one closed cup compressor will be provided here, humidity and air movement. So the test rig consists of the closed type, so this is the closed type compressor. So you will be having an energy meter here. So this is energy meter, so which is used to measure the electrical input to the compressor and the heater. So and then you will be having a pressure gases. So pressure gases will be provided here. So that fours are the pressure gases, and the thermocouple sensor fitted at the respective locations. You will be having a thermocouples at different locations, and these values can be noted in this temperature indicator values. So this is and then you will be having an air cooled condenser. So condenser will be here, and an expansion valve. Expansion valve is there, etc. And then air cooled type evaporator is also provided. So first the air is passed by the blower unit through the duct. So now the blower is switched on. So the air is passed by the blower through this duct. So this is the duct. The air is flown inside this duct. The expanded refrigerant then passes through the coil fixed in the duct. So these are the coils that is fixed in the duct. Through this the refrigerant passes through. The passing air comes in contact with this coil. So the air which is coming from the blower will touches this refrigerant. A multiple air heater is provided in the duct for dehumidification. For dehumidification process, so at certain locations you will be provided with an heater. So this is the switch for compressor, and this is the switch for condenser, and this is for blower. For measuring the temperature, you are having the switches. So wet bulb and dry bulb temperatures of the air stream can be measured with this indicator. So the airflow which can be measured by an anemometer. So the whole unit with the panel and the air circulation system mounted on a trolley with caster wheels. So then the pipelines are suitably color coded to indicate the different states of gases. So what is the procedure is first you have to switch on the mains, then switch on the compressor fan, condenser fan and blower. So keep the manually operated valves in the proper positions. So that valves has to be kept in a proper position. So then you have to switch on the compressor. First you have to switch on condenser, then blower and then only the compressor, and allow the unit to stabilize after adjusting the airflow through the duct. So you have to wait for some time for attaining the steady state condition. So then you can measure the pressure values of the superheated vapor on the exit of the compressor. So that is denoted by P1. So then pressure at the entry of the throttle valve. So this is P2, and pressure after throttling, which is P3, can be measured from there. And pressure of superheated vapor at section of the compressor, which can be P4, that is measured from the fourth one. So as well as you have to know the corresponding temperatures T1, T2, T3 and T4 at respective state points. So then you can find the COP of this experiment by using a pH chart, that is psychometric chart. So you can take the H1 value, H2, H3, H4 values from the psychrometric chart. So from that you can determine the COP, which is H4 minus H3 divided by H1 minus H4. So next is power input, which is 3600 into 10 divided by E into T in terms of kilowatt. So where E is the energy meter constant. So performance of the unit, which is refrigeration effect divided by power of the compressor. So how can we carry humidification process here? So if moisture is added to air, but its dry bulb temperature is maintained constant, means that process is called as humidification process. Okay, so similarly we can also do an dehumidification process in this equipment. So if the moisture is removed from the air without changing the dry bulb temperature, so then the process is called as dehumidification process, which can also be done with this experiment. So this is the tabular column for air conditioning test rig. So T1, T2, T3, T4, P1, P2, P3, P4. So these values are already said. You can take it from your experiment. So inlet readings, that is wet bulb temperature and dry bulb temperatures, you can note it, as well as outlet readings of wet bulb temperature and dry bulb temperature can also be noted. So then time for 10 revolution of energy meter of compressor, which can be noted in this energy meter. Ammeter reading can be noted in terms of meter per second. So next, time for 10 revolution of energy meter of compressor can also be noted. So for dehumidification and humidification process, what is the outlet readings of dry bulb temperature and wet bulb temperature can be noted here. So for calculations, the required parameters are energy meter constant, which is 1200 revolutions per kilowatt hour. So then diameter of the orifice, which is fixed to the duct, is 0.08 meter. So next, area of the orifice, which is fixed to the duct, is 0.005 meter square. You can determine the density of air and mass flow rate of air by using this formula. Then from psychrometric chart, from corresponding inlet dry bulb temperature and wet bulb temperature, the enthalpy values can be noted. Similarly, from the outlet dry bulb temperature and wet bulb temperature, from the psychrometric chart we can find the enthalpy. Then we can determine the drop in enthalpy. So that is the difference between your inlet and exit enthalpy. So you can get 30 kilojoules per kilogram. So for mass flow rate of air method, and the drop in enthalpy or the refrigeration effect can be calculated. So then power input, so which is already discussed in the previous one. So that is the formula for power input, and performance of the unit can be calculated by refrigeration effect divided by power input of the compressor. So these are the enthalpy values H1, H2, H3, H4 corresponding to inlet and exit values. From this we can find the coefficient of performance of this air conditioning test rig. So this process can be carried for humidification, dehumidification processes, or a combination of the process can also be done with this air conditioning test rig.